Now let's store the values of our velocity at particular time so that we can plot those values. For that, let's have for that, since we need to store the velocity with its corresponding every time, the time with its corresponding velocity, then that means that we need to have an array to store the values. So let's have an array of zeros. Now let's have an array of zeros with dimensions equal to the as you may have noticed in the previous, the number of let's say here, for example, this one, the number of rows from 0 to 12, it's actually the time final minus time initial over 2, over the step size, then plus 1. Okay, for example, this one. Therefore, our dimension here should be t final minus t initial divided by step size, then whole quantity plus 1. Okay, so that will be the number of rows. Okay, let's just put this as rows. Okay, so we'll have these number of rows with just one column. Still also the same with y. Then here let's store these values of v and t. Then we'll also, before that, we'll also need an index. So let's have I equal to 0 as our index. Then let's have let's update the I every iteration. Then let's store the value of v and t. Okay, I'll put it this here. Then let's store the value v x our x will be for our time. It will be time. and our y will be for our velocity. So that's okay. Before we print our time and velocity, okay, then since we are going to store this, maybe we don't need to print this every iteration. Let's just print the whole. Yes, let's just print the whole. And then okay, since this will be, the use of this will be to update, then, and we are storing time, so we need to transfer this one here, so that if dt is equal to 0, the time won't be updated anymore. Otherwise, if we did not do that, the time here will be the updated one, which has plus dt. Okay, then let's what other else, let's print let's display, let's okay, let's now store, since x, y, okay, we can have x, y, let's see this. Invalid syntax at line 24. Express output within a script. Maybe this one. Let's try that. Okay. Let's try if this will do. It won't save. Why? Still maybe off the connection. Still won't save. This is one of the problems when you use Matlab online and you don't have a good internet connection. we have to wait that this will be saved, then we can run the program. Let's copy this and let's try to refresh. Okay. Unrecognized function or variable t. It's from line 9. It's time. Should be time. Okay. No, it's not time. It's t final. It's t final. Okay. V at 6:30 68:12. Why is this different? Okay, yes, it's because it's the analytical, so I have to follow this. Okay, yes, okay, that's correct. Now we were able to store this. Wait. Oh, wait. What we did earlier was not saved. Okay. Okay. Wait. It should be the final. Okay, we were not able to display this. Let's display this. Okay, so this is, yes, that's correct. Okay, But I guess we don't need this one. Maybe we can have, okay, instead of this one, this percent sign, it's to make a comment. So I transform this one into a comment so that our program will not read this one. Okay, let's have dimensions of rows and 2. Okay, then this one, this will be oops, okay. Time will be at the first column. Velocity at the second column. Okay, I think we don't need this one. Let's try. Oh, wait. It should be I. Oops. Okay, so that's it. Now, having stored these values, we can then later we will use this to plot the graph of our analytical values as well as our numerical values, to further illustrate our answers. So I think that's all for the analytical part.